The graph illustrates the distribution of test scores taken by college algebra students. The maximum possible score on the test was 140, while the mean score was 80 and the standard deviation was 14. What's the approximate percentage of students who scored between 38 and 80 on the test? All right, so 38 is here and 80 is there. So 80 is the mean, so I'm going to mark that as 0 as the mean. 38 is 1, 2, 3 standard deviations below the mean. So the region that I'm looking for is this amount of area here. So let's see how the empirical rule could help me find that. So the empirical rule, it gives us a set of percentages to associate with how much data is between a number of standard deviations. So for instance, it says there's about 68% of the data within 1 standard deviation of the mean. There's about 95% of the data within 2 standard deviations of the mean. And about 99.7% of the data within 3 standard deviations of the mean. Now it's this last one I think that's going to be helpful because we're interested in something that's 3 standard deviations away. But the problem with that 3 standard deviations, the problem with the 99.7 is it isn't just 3 standard deviations to the left of the mean. It's actually 3 standard deviations to the left and to the right as well. But the thing is, the distribution is perfectly symmetric. So there would be, separate from the mean, if there's 99.7% both directions, there would be half of that in this direction. So 99.7 divided by 2 is 49.85. So there would be 49.85% either direction. So that's the value that we're looking for here. 49.85. What is the approximate percentage of students who scored higher than 122 on the test? All right, let me get rid of all my markings here so we can start anew. Higher than 122. Okay, so here's 122, and we want students that are outside of that range. Now notice, so here's my mean of 0, so this is 1, 2, 3 standard deviations above the mean. So again, I think we're interested in this 99.7 to help us out. But here's the thing, that 99.7 is the total area within 3 standard deviations. All right, so from here all the way to here, that's 99.7% of the data, which only leaves 0.3% in the tails. But there are 2 tails here, and the distribution's perfectly symmetric. So I think we're going to take 0.3% divide by 2. So that would leave 0.15% of the distribution's area in that upper tail that we're interested in. What is the approximate percentage of students who scored higher than 108 on the test? Well, using the same sort of argument, we need to first come up with how far away 108 is in terms of standard deviations. So that's 2 standard deviations away. Now, this 95% would give me the area under the curve between 52 and 108. But what I'm interested in is, of course, this tail, this direction. But since I know that between these 2 values is 95% of my data, according to the empirical rule, I can do the complement of this. So 100% minus 95% gives me 5% left over for the tails. But that's in both tails together. So that leaves this upper tail to be half of 5%, which is 2.5%. And lastly, what is the approximate percentage of students who scored between 66 and 80? All right, so between 66 and 80, again, we just need to get familiar with what values we're working with. So 66 is here, 80 is there. So that's the region that I'm interested in. So this amount there. Since that's one standard deviation below the mean, the value that is helpful is going to be the 68. But of course, that's going to be the area all the way across from one standard deviation below to one standard deviation above. So what I need to do is just, again, take advantage of the symmetry of the distribution and take half of that. So if I take 68% divided by 2, then that would give me the area that I'm interested in, which is just 34%.